Good morning. Today we shall go for the second part of dimension analysis, that is expression of physical quantity. So what is this actually? By using this method we can derive any type of expression, that's any type of formula, by knowing only on which quantity it depends. Let's say I shall start with the very easiest one, as I always do it. So I shall do the easiest one and I give you another one which will be of course harder than this one. Okay, so I'm saying that, let's say this is a pendulum which is suspending. This is the length of the pendulum, that's mean the effective length of the pendulum, not the length of the string, rather the effective length. And t is the time period of the pendulum, m is the mass of the bob, g is the acceleration due to gravity. Okay, so what I'm saying that let's say the time period of a pendulum, t, that depends upon the mass of the bob. Okay, how depends, I do not know how it depends. The mass of the bob, the length of the pendulum, and the acceleration due to gravity. I just know it depends upon this. The how it depends, I do not know. Means whether it is proportional or inversely proportional or proportional to the squared, I do not know. Okay, and you are asked to find what is the formula for t. Okay, so I am taking, let's say I am taking like this, doing here, let t is proportional to m to the power x. So if t is proportional to m, then x will be 1. If t is inversely proportional to m, then x will be minus 1, like this. And t is proportional to L to the power y, and t is proportional to g to the power z. I am doing like this. So when I combine these three, what we shall get? Proportional to m to the power x, L to the power y, g to the power z. Okay, or I can write like this: t equal to a constant k into m to the power x, L to the power y, g to the power z. Now to derive the formula, what is our aim? Our aim is to find the value of x, y and z. If we can derive the value of x, y and z, we can calculate t. Okay, now using dimension analysis, let's put the value, let's put the dimension of t as well as the dimension of k, the dimension of m, the dimension of L, and the dimension of g. Okay, so this is time period, its dimension of course is t. This is a constant, dimensionless quantity of course. The dimension of m means mass, that is capital M. The dimension of length is L, and the dimension of acceleration due to gravity, that is the dimension of acceleration. You have to memorize this, that is L into t to the power minus 2 to the power z. Last class I have told you. Okay, so now do some mathematics of indices. So this is m to the power x, L to the power y, and here L to the power z from here, and t to the power minus 2z. And here we can write m to the power 0 as no m is here, L to the power 0 as no L is here, and t to the power 1. So we can write from here m to the power x, L to the power y plus z, and t to the power minus 2z as it is. Now comparing both sides, m to the power 0, L to the power 0, t. Compare both sides. What you will get? You will get x equal to 0, as power of m and power of x is 0. So x equal to 0. Okay. Y plus z equal to also 0, because this is L to the power 0 and this is L to the power plus z. So I can write y plus z equal to 0, and y equal to minus z, keep it, and minus 2z equal to t to the power, actually 1 is here, so minus 2z equal to t to the power 1. Just comparing the power of minus t and here the t, so minus 2z equal to 1, or z equal to what we can write? Minus half. So z equal to, we are getting minus half, so minus of minus half, that is y equal to plus half. Okay, so I have got the value of x, y and z, x, y and z Now put the value here. What we shall get? Sorry, put the value here in this equation. Okay, so what we shall get? T equal to k, leave as it is, m to the power x means m to the power 0, l to the power y means l to the power half, and g to the power minus half. Okay, so m to the power 0 means 1, so l to the power half means root over l, g to the power minus half, so I can write it like this, g to the power half. So from here what we can write? T equal to k into root over l by g. You know this formula very well, and experimentally we can show that k equal to 2 pi. How experimentally we can show, I do not know. Okay, and to know this you have to do a lot of experiments. Actually we shall do, of course we shall do in lab, but from here I can write t equal to 2 pi root over l by g. This is a well-known formula for you. Okay, now I shall give you another one from the exercise. Tomorrow I shall give, I shall give you now. Okay, the next thing,